Have you ever found yourself asking yourself how I can predict my medical costs by using my weight and my height? If you have, you're not alone. A lot of people ask these questions. As you know, 2023 is just around the corner, and we want to predict what's going to happen in the next year. In this video, I'm going to show you how you can predict your medical insurance cost by using weight and height by leveraging machine learning algorithms. Hello, my name is Sina Shariati. I make people feel confident about the machine learning world. If you are a beginner, you can understand the machine learning concepts with the easy language. And if you are expert, you can refresh your knowledge in this channel. In this video, I'm going to talk about how we can predict the medical cost. And for the sake of this video, we're going to use a persona and we're going to try to predict the medical cost for a lady. Without further ado, let's jump in. For the sake of this video, I'm going to use an impersona, and we are going to predict the medical cost for a girl. The girl is not a smoker. She's 28 years old, has 3 children, and lives in California. We want to see how much the medical cost would be for her. Hello guys, in this video, I'm going to show you how we can use machine learning board to predict the medical cost. If you're living in the US or somebody living in the US and you want to predict the medical cost for them, this video is for you. To do that, we're going to follow 4 different steps. The first step, we're going to import all the libraries we need and the data. Then we're going to prepare our data to build our model. Then we're going to build the model using neural network. And finally, we're going to make our prediction. First, we're going to import all the libraries we need for this video. So we need a couple of libraries from data structure. We need some machine learning libraries, and we need a visualization library. You can see all the libraries we need in this line of code. Then we're going to prepare our data. First, we need to import the data. For this video, we're going to use the dataset named insurance. The insurance is the data related to the people living in the US. And you can find this dataset on the Kaggle. Finding is so easy. You just need to Google it and put insurance on Kaggle and go to the Kaggle link, and on the Kaggle, you can find the raw location. And if it's not easy for you, you can use this raw location here. I put the whole raw location here. If you type this location, you're going to get this data set. By using the read underscore CV CSV function, we're going to import, we call this data set and import it into the variable named data. Then we're going to take a look at the data shape. The data shape shows us how many columns we have in this data set and how many observations. By taking a look at that, we can see we have 1,338 observations and 7 different columns inside our data set. By using the sample function and feeding the number 5, we're going to get 5 randomly row of that data set. You can see here, these are all the 5 randomly rows of the data set. You can see all the column names on the top: age, sex, BMI, children, smoker, region, charges. And if you just take a look at the whole data, you see the sex has categorical variable, female or male. The smoker also is categorical. You can see the values are either no or yes. The region also are categorical. As in this video, we're going to build artificial neural network. We need to convert all the category variable into the numerical variable. And the reason we're going to do that, because the artificial neural network doesn't accept categorical variables as input. That's why we need to convert all the categorical variables into numerical variables. And also, we're going to behave the last column, which is charges, as a response variable, and behave the other columns as predictors. Then we're going to check if we have any missing values inside our data set. By using isNull function, then some function, then some function again, we're going to get the one number, which is 0. So it shows we have no missing values. So we don't need to do anything regarding the missing values. Because if we have missing values in a data set, we need to handle that situation. Then we're going to define the predictors and the response variable. First, we're going to make copy of our data by using the copy function, and we put it into an X variable. By using drop function, we're going to drop the charges column. If you remember, we're going to behave the charge as a response variable. Then we're going to convert all the categorical variables into numerical variables by using what function? The function is replace. And you can see we are giving here, for example, for the smoker column, we are giving yes number 1, and we are giving to the no number 0. And for the sex column, we are doing the same. We are giving the female number 1, and we are giving the male value number 0. And for the region, we have 4 different regions inside our data set, inside the column, the region column. And you can see the numbers we are giving to each value. For example, number 3 goes to southwest, number 2 goes to northwest, number 1 goes to southeast, and 0 goes to northeast. And here on the line of 8, we are defining our Y variable, which is response variable. Let's take a look at X after converting all the categorical variables to the numerical variables. So you can see here age, sex, BMI, children, and smoker region. You can see the sex is converted to the numerical variable. Smoker is converted to a numerical variable as well, and the region the same. And if we take a look at the data type by using info function, we can make sure, okay, all the columns we have right now are numerical. Integer 64, integer 64, float, integer, integer, integer. So we are good to go. We can jump into the building process. But before that, we need to split data into training set and the testing set. To do that, we're going to use the train test split function. We need to feed this function by X, Y, the test size, and the random state. You can see here we are defining the test size as 20%. It means we are giving 20% of our data set to the testing set and 80% to the training set. And we are inputting all the splitting, all the data set into X train, X test, Y train, Y test. Then, if you remember, we have different magnitude for each column, right? So that means feature scaling comes to play. We need to scale the data. To do that, we're gonna instantiate the standard scaler. A standard scaler is a standardization, is a feature scaling method. We have other feature scaling method, which is called normalization, but we are not using that here. Anyway, first we need to instantiate the standardization by running the standard scaler. We are getting this function from the, if you remember, from the library. And the library was pre-processing. It's located on scikit-learn. Then we're gonna fit the scaler, and this function gonna get the average and the standard deviation for each column. And then we're gonna apply that transformation on the X train. Then we're gonna apply the same transformation on the X test. So right now our data is ready. We are good to go to jump into the building process. To build a model, we're gonna use the artificial neural network algorithm. So here in this video, we're gonna create the model from scratch. That's why we are calling the sequential. We are using the sequential function. Sequential function gonna start the whole process. I mean the structuring process. By using dense function, we're gonna add the layer, another dense function, add another layer, another dense function, add another layer, dense function, another dense layer. And the last one, which you can see we are feeding the number one because we have just one response variable. To keep this video as simple as it is, I'm not going through all these variables, but if you have any questions, please feel free to reach out to me. I'm happy to answer your questions. Then let's take a look at the summary. We want to see what we built so far. And by using summary function, we're going to see what's going on regarding the structure. You can see here, these are different layers: first layer, second layer, third layer, fourth layer, and the last layer, right? And the total params we have couple trainable params and non-trainable params. If we do different way, for example, if we were using pre-trained model, we would behave different. But again, because for the simplicity's sake, I'm trying to keep this video as simple. Then we're gonna compile the model. And here we are feeding the optimizer Adam. The loss function gonna be mean squared error. And the metrics we're gonna use is MSE. MSE stands for mean squared error. And we're gonna use this metrics to evaluate our model performance. And finally, we need to fit the model to build our model. So you can see we are feeding our fitting function by X train scale, the Y train validation split 25%, and we are using epochs. We are using 20%, 200 for the epochs, and you can see all the 200 epochs here. If we go all the way down here, we are done with the the last epoch, 200 over out of 200, and by using matplot library, we're gonna display what happened regarding the metrics. If you remember, we use mean squared error as our performance evaluation, right? And here you can see as we go, as the epoch increased up, our mean squared error decreased down, which is good sign. So let's take a look at the R2 square. This is another way, another criteria to see our model performance. We are importing it from the scikit-learn, the metrics. And here you can see we're getting the Y prediction for the X test scale by using the predict function. And then we're going to print R2 square. And here you can see once we print the R2 square, R squared score, we call it, machine learning speaking, is 85%, which is good. 85% is so good. And let's take a look at what's going on regarding our prediction. So you can see here again, we are getting the Y prediction by using our model. We are feeding the model, the X test scale, and we are using the flatten function to flat all the, the NumPy, we flat it. And then by using matplot function, which we call it PLT, PLT stands for matplot. Here, you can see all the prediction fall along the straight line with the slope 1. So here the X dimension is true values and the Y dimension is predicted values. And you can see we almost have all the points. This is the scatter plot. And we have all the points on the straight line with the slope 1. If you remember, we got R squared as 85%. So you can see that's why we are getting this line. And it's so good. And then just bear in mind, we gave the smoker who is a smoker, number 1. We gave a person who doesn't smoke, number 0. For the sex, we gave female 1 and male 0. And for the region, we gave northeast 0, southeast 1, northwest, and southwest 0. And finally, we want to make prediction on our in persona. If you remember, we want to predict how much would the medical cost for a lady. She's 28 years old. She doesn't smoke, and she has 3 children. Her BMI is 20, and she lives in California. So first, let's look at the columns. We are getting the name of columns because we want to feed our model, and giving all these info to each these columns, right? So here, the first column is age. We are giving 28. Second one is a sex. So she's female. We are giving 1. BMI, we are giving 20. And we can calculate BMI by using height and the weight, right? There is a formula. You can use that to calculate the BMI. It's so straightforward. She has 3 children. We are putting 3. She's not a smoker, so we are entering 0. And she lives in California. If you remember, California is the west, here, southwest, right? So we are giving number 0. And Lala here. So her medical cost annually would be $6,196. Okay, it makes sense for a person living in California. She has 3 children. She doesn't smoke because, smoke affects their health. And finally, I have something for you. I have an assignment. Imagine you have an insurance company and you have a client and you want to predict the medical cost for your client. And your client is a man. He is 45 years old. He smokes and he has no children. And he lives in New York. So how many dollars would be his medical cost for a year annually? And right now we can mark the end of this video. Guys, if you like it, please subscribe it. And if you want to see more, please subscribe it. You're going to see more similar video. If you like it, please give it thumbs up. And if you think it can help somebody else, feel free to share it with your friends or anybody else. Thank you so much. Have a good one.